Okay, so my name is Todd Carter. I'm the CEO founder of Tagasaurus. I'm going to take you through a little story and then try to create a portrait of sort of the entrepreneurial side of the story. Chris laid out this wonderful kind of vision of the science side of cognitive computing and what they did with Watson. We're coming at this kind of more from the multimedia semantics side. So our interest area is multimedia semantics, multimedia analysis, multimedia interaction, and how all that sort of fits together. And so I'll take you through a story about that. So Tagasaurus is a New York City-based startup, initially funded by NYU Innovation Ventures. Our aim is to build an intelligent data platform for visual content. And we talk about content-aware and relationship-aware images and video. I'm going to give you some background on that. But first, just a little bit of history for context. So in 2009, I was approached by an organization named Magnum Photos. It's a photography cooperative. It's made up of 60 members. It's the most famous photography cooperative in the world. They effectively invented photojournalism. It was started, if you know about photography, by Henri Cartier-Bresson. Every one of these pictures comes from the Magnum collection. It is one of the most amazing archives in the world. The problem they had was that they had, over the years, over 60 years, 65 years of shooting great photography, they had amassed this massive archive of images. And as technology moved from traditional prints in a library with librarians and to the internet, people were no longer querying this library by kind of going physically to the space and looking through the file cabinets, but they were interacting with it online. And they were troubled that their sales were plummeting, people weren't able to find images, and they asked us to look at the problem. And it turned out that most of the images in the archive had no meta information about them. They had no data at all. And so, you put at that time in 2009, computer vision was almost a kind of joke. I mean, it's gotten serious in the last 2 years maybe, but in 2009 it wasn't very impressive. And so the only way that anybody thought about making any of these pictures discoverable was to hire a bunch of history experts and have them sit in a room and annotate pictures all day long at a cost of $3, $4, $5 an image to do this work. And at that time, we hypothesized that to Magnum, that we could set up a crowdsourcing process to look at this archive and to collect data. And they said, they're kind of crazy, so they said, try it. And so we did. We set about trying this. And we built a few prototypes. And in the course of building those prototypes, we sort of started to think about the idea of using Freebase as a corpus, as a controlled vocabulary to annotate photos. In other words, not to annotate photos with words, but to annotate photos with entities that had URIs, that there was a label, an HTTP URI, a link to a bunch of metadata about that, and then sort of like a kind of graph structure on the back end that you could use to do, kind of meaningful types of expansions. So an expansion would be something like, oh, this is a picture of Arnold Schwarzenegger, and then the expansion is, well, he's a governor, he's a politician, he's a bodybuilder. So you get all this kind of extra data for free. And so we set about this process of trying to annotate this archive. And I'm going to tell you a little bit about how we did that. Let me just jump forward. This presentation is about how we did that and where we're taking that today. So just a few data points, in terms of things that we believe, right? So we believe that images are not inherently smart, right? They're not inherently readable by computers. If we were to look at this image with a computer, we'd know it possibly has a file extension. We might be able to determine its color space, its size. I fed this exact image, through a half a dozen of the best AI systems for computer vision this morning, and we got results like it's an airport departure lounge. Literally, this is a Trek. This is the system that won Trek in 2013. Thinks this image is most confident judgment is that this is an airport departure lounge. The moon, various celestial systems, etc. Nothing even close to a guy underwater swimming. So this is a real problem, that visual content on the web isn't smart. At the same time, that's the fact, we believe that visual content is actually the currency of sort of the web tomorrow. So the web is increasingly a visual place. People upload I think it's 1.5 billion photos every day, 100 to 120 hours of video to YouTube every minute, if I'm correct. So the web is this incredibly visual place. Well, let me say the internet is a visual place, but the content really isn't connected, and it's not connected in an intelligent way. And so we've heard a lot of people, you hear people talking, investors talking about a new visual web. I think it's a sort of a misnomer, because the part of the web, the part of the internet that's visual is not a web at all. It's more analogous to a landfill, because it's just images piled on top of the web with no way to reason between them, no way to connect the dots, no way to create a narrative. If you think back to the Magnum Archive, these people were storytellers. They were people that told stories with images. And, when you think about how we interact with images online, I mean, there is no sort of narrative thread. There's no way to pick an image as a seed and string together a narrative, a story from that. And we think that's sad. So we believe that once visual content is intelligent and connected, that it's going to unlock a kind of new generation of applications, a new generation of learning applications, of exploration applications, and that's something that really excites us. It's those beliefs that images aren't smart today. I mean, that the web is becoming an incredibly visual place, that images aren't smart today, that in order to make them smart, they need to be connected intelligently, and the kinds of things that you can do when they are connected intelligently, it's those beliefs that drive everything that we do. So we have this idea that we can use metadata, and I'm using that sort of generic term, but for us, it's semantic metadata. It's linked metadata, data with a URI, that follows the principles of the semantic web. We believe that we can take dumb images and make them content aware. And so this example of this image of the New York City skyline, New Jersey, Hudson River, the MetLife building, the fact that it's a sunset, the skyscrapers, that it's New York City. This is the core of what we did for Magnum. We took 2 million images, we ran them through a process to make them content aware. And that process is what Chris was referring to in his talk. It's a human-assisted compute process. So what do I mean by human-assisted compute process? What we did is we said that humans, we wanted to combine humans and computers cooperatively, so that the sum of what they were doing would be greater than the individual parts. That humans are good at doing certain tasks, but they're very, very expensive. Computers are doing good at other kinds of tasks very cost efficiently, but sometimes they're not accurate. And then by combining the two, we could get outputs that neither constituency would achieve in isolation. And we built a human-assisted compute platform that uses a combination. We started out with the Mechanical Turk marketplace, but we also had entity extraction systems for text, and we had systems for computer vision, and we would combine those all together. And we could use the humans to train the underlying computer systems, or to adjudicate the output of the underlying computer systems, or to just, if we were looking at some kind of information, some kind of photograph, and we needed to interpret just some sort of level of interpretation that a computer would be impossible for a computer to do. So when we think of tagging images, we think of sort of a matrix of general, specific, abstract, who, what, when, where. And so you could imagine that humans would be extraordinarily good at the abstract aspects of annotation where computers might not be so good at that, and that turns out to be the case. And so we try to bring them together cooperatively to create this kind of rich descriptive meta information. And just another quick word about human-assisted computing is, because we were using, there's a professor at NYU, his name is Clay Shirky, and he wrote a cool book called Cognitive Surplus. And Cognitive Surplus looks at things like that it took 20 million man-hours, I think, to build the Empire State Building, and 100 million man-hours to build Wikipedia. And it turns out Americans spend like 2 billion man-hours a year watching television. And about the same for Europeans, and about the same for Asian countries. So that's Wikipedia produced effectively in a weekend of American television commercial viewing. So you think about that, see, well, if you could tap that, you could really do things. And so that was the idea we had. If we could tap into sort of human surplus, we could send these images out into a labor market like Mechanical Turk, and as Chris was saying in his talk, we could use repeated labeling. We could collect a plurality of judgments from these things, and we could look at those judgments, and we could look at where there was agreement, and now we've learned over the last few years where there's disagreement. And we could use those to create rich descriptions. And so this is the idea behind this human-assisted compute stack. So that was where we kind of cut our teeth. That was the first part of Tagosaurus. But as Chris points out, semantics gives you something that you don't get you don't just get by tagging things, right? So something like Freebase or a graph database in the background, it allows you to take this sort of content-aware image and begin to make it relationship-aware. And this is really where the power of, I think, what was happening for us, when we first started chatting with Chris, the power of this idea of connecting this to a big graph database where we would mine a lot of data from community data sources like GeoNames and Wikipedia, and we would align that data with things like WordNet, so that when we labeled an image with the word skyscraper, that would automatically be connected to the concept of architecture, or to a building like the MetLife building, which, by the way, used to be called the Pan Am building, which used to house Pan Am Airlines, which is associated with air travel and a famous helicopter crash that occurred there. And you can start to walk around this graph computationally, and it really reveals how things relate to one another. And so we thought that was an incredibly powerful technology that could be brought to bear along with human-assisted computing to make visual content more connected and more engaging and more discoverable. And the other thing that's kind of interesting is, we kind of cut our teeth applying that to images, but you can apply that to video as well. And you can apply that to video in a really interesting way, which most people don't realize. But the W3C has standardized something called the Media Fragments URI. And the Media Fragments URI allows you to take video and in a browser resolve it, break it down by time, that's called the temporal dimension, or by time and space. So you have a spatial dimension, which is like an XY coordinate within the video. And you can address all that in just browser URLs. So you have support for this today in Firefox and Chrome and Safari. And so what you're able to do now is take video and break it down on a shot by shot or shot and scene or any kind of arbitrary interest event, and then associate all this kind of linked data with it. And this allows you to start to think of making hyper video, right? Video hypermedia. I mean, that's an old term, but it's a powerful concept, right? What if all of this audio visual content on the web could be linked together like the web is linked together, right? If the video could be linked and the topics expressed in the video could be linked, and it could be linked not only within that data type, but across data types. And so this idea of making and minting hypermedia on the web is something that's really captured our passion and imagination. And so semantics lets us do that, right? It lets us turn this sort of visual content into relationship-aware content to identify the objects, the subject matter of the material as entities, to differentiate them from one another, to manage same-as equivalence. So look at how many different ways people would say New York or New York City, or how many times, Chris said there's how many Torontos? 7 Torontos in North America. Which Toronto are you referring to, right? So an entity allows you to explicitly know which Toronto you're referring to. There's 26 different Bostons around the world, right? Not to mention the Boston Bruins or the Boston Celtics. And so with entities, every one of those things gets sort of a unique identifier. And then we manage all those entities in a technology called a triple store, which is a kind of a graph database. And then we put a kind of hypermedia API on top of that lets you query that database for these relationships. So why do we find this sort of content-aware and relationship-aware material so exciting? So I'm going to just take you through a few examples of that. So if you think about the newspaper, even the online newspaper, the Washington Post. The Washington Post is the same online it is in print. It maybe has a link structure that you can click, but the image on the page is just as static as the image in the print page. There's nothing you can do with it. Your experience stops there. So for the Washington Post, we want to be able to take a story about something like the anniversary of the Eiffel Tower and light it up. Right? Just be able to click on that image and use that image as a kind of query document, a kind of window into a whole world of relationship, sort of aware visual experiences. So we can bring up related content from the Washington Post. We can bring up maps of where the Eiffel Tower is on the Champ de Mars in Paris, or we know that Gustave Eiffel was involved in the design, or we can collect media from social media about it. So it allows us to really start to rethink publishing in a more visual world, in a world of touch, a world that I think is more intuitive to people than just pure text. For broadcasters, we have found that you're watching a TV show, there's something interesting going on, you want to learn more about it, you pick up your computer or something, you're off exploring the internet. How do you bring all that together? And so we've been exploring how to do that with some of the biggest entertainment companies in the world, how to take a contemporary TV show and break that show down into a series of shots and scenes automatically, and then link all the entities under the hood. And so we're showing an experimental interface here that was actually designed by Laura Roro at VU in Amsterdam, but actually with content from one of these entertainment companies. And you've got filters that allow you to explore things by people, location, entities, and the images that occur. This is all sort of a swipeable interface. The entities that occur on here are all related to this character in this specific episode, because we look at things like character co-occurrences and we can count those. We can use computer vision systems and humans to count and manage all of those kinds of annotation tasks, and then the system can just sort of spit out the co-occurrence of how many times a character occurs on screen with this actor in a single episode, or in a season, or across an entire series. And as I said, we're not only annotating the content, but you're able to, I hate to get commercial, but as a startup, you have to sometimes think about where and how you're going to generate money. So you have the ability to sort of Shopify all those scenes so that as the video plays, you can show the different products that are depicted in the scene more or less in real time. And so that's a world that we're working on in the entertainment space. And then for education, we've been working on a project called HyperTED. And the idea here was to take the TED corpus. We took all 2,000 TED Talks and break those down by shots and scenes using natural language processing to traverse the transcripts, to create automatically, here's an example, picture of the application, to create hotspots within the video, so you can query for things like linked open data, find every single TED Talk that has the term linked open data in it, jump directly to the fragment that has that talk, and then it'll recommend other talks based on those fragments. So it's this idea of building hyper video, and we just, in this case, use TED as a corpus. But if you think about that as an educational resource, I mean, how many times if you're looking for some trick or some Photoshop trick or some technique somewhere and you don't want to watch the whole lecture, you just want to jump to the part in the lecture that has the thing you're looking for. That's what this does. And then of course we expose all that to the Google search ecosystem so that you can now find that using the standardized search tools and jump directly to the fragments within the video that you're interested in. So that's pretty cool. You take 2,000 TED Talks, maybe you have an average of 10 fragments per talk, so you've just pushed 20,000 new searchable entities into the Google search index, which is a very cool idea. And I think there's a whole question. I mentioned SEO. I mean, with the Magnum project, after we annotated all that content, we annotated it, then pushed those annotations into the Google search index again, and we drove traffic to their site by 5,000%. So it was a 5,000% increase in traffic by just annotating the assets and then exposing the annotations to the existing search ecosystem. And this is exactly was the thinking with HyperTED as well, is we could make those fragments more accessible, make the search ecosystem smarter, and then deliver more of a kind of relationship-aware experience with the content. And so just a couple places, where we're doing this. We've been working with some big entertainment companies. We've been working for years with large archives, the New York Times Photo Archive, the Rogers Photo Archive, the Washington Post, the Museum of the City of New York, Magnum, and increasingly, with people that are trying to syndicate both photography and visual assets, and then try to link those assets together into some kind of new information resource. So just a quick view of that. Chris, for us, this is a really challenging thing for a startup. I think when we started this, we were like, okay, this is cool. We're going to be a crowdsourcing company and we'll tag photos. Well, this actually turns out to be really hard. There are a bunch of disciplines that you've got to become expert at. We've started out in the human-assisted computing space. These are a bunch of companies we work with. We have had to get good at machine learning, and this is an area that is going to take on more and more important for us. Deep learning, cognitive neural networks around things like computer vision is an area we're really interested in. Semantic technologies, I mentioned we work with Freebase, but today we've stood up our own knowledge base that combines Freebase and DBpedia with GeoNames and WordNet and a bunch of other resources. And so the idea that we've had is if you bring all of these sort of technologies together, you could build a kind of, I'll say a kind of concierge, that some kind of cognitive service that could reason over networked audiovisual information, right? We've got this potential for a ubiquitous cloud of networked audiovisual content, and increasingly that's how we express ourselves today, right? Our culture expresses ourselves visually, and if you could reason over that visual culture, if you could make that computational, our sense is that would usher in sort of some fantastic new kinds of applications. And our sense is it takes all of these set of skills to make that happen, and others too. But that just gives you kind of a roadmap for at least how we view the world. Just a quick slide. The important people really are the science people that make all this happen. Panos and Laura have been incredible resources. Panos is one of the experts in human-assisted computing, and Laura is too, has worked with Chris carefully on a bunch of stuff on Watson, on crowd truth, this idea of using crowdsourcing to mine disagreements, and that the disagreements turn out to be one of the areas where you get the most meaning. So an example of this is if you're trying to understand events like where does World War II start. I mean, it's a really simple model, but it's different if you're in Europe or if you're in Asia. And so there is no exact right answer to that, right? The answer to that is sort of fuzzy. And so she's been instrumental in working on that problem with Chris and has been helping us in many, many ways. So that's sort of just a quick presentation on what we're up to. As I said, it's an entrepreneurial endeavor. We're trying to do something I think that's pretty hard to do. And so I thought it was interesting because it combines kind of entrepreneurialism with computer science and gives you guys hopefully an idea of how we're trying to apply some of the kinds of things Chris was talking about to the in an entrepreneurial way to make culture more accessible to people. So. Thank you. So, questions? Sure.
So, how do you deal with misrepresented information or incorrect data? For example, on Freebase, let's say you use for movies, we use IMDb, right? IMDb as a source that puts in information in Freebase, and that's what you use right here. So if, let's say, something was wrong, and it's been there, so on the UI here, how do you deal with that?
So yeah, I mean, this is we kind of look at these systems as, we think of this sort of as collective intelligence, and there's often mistakes, right? So there's lots of mistakes in Freebase. So, and the other challenge is, we don't have complete control over Freebase, right? We were a consumer of Freebase, we contributed to Freebase, but we didn't have the control we wanted. So the first thing we did is we ultimately stood up our own knowledge base. So that knowledge base has lots of mistakes, just like Freebase, probably more, frankly. And then we stood up pipelines back to the places we get the data from, places like Wikipedia, to monitor those sources for changes and updates, and then we re-import those things so that we have the latest, most up-to-date community data. But to the extent that there's mistakes in that data, we have the mistakes. And we live with it, because where are you going to get 100 million man hours? Where are you going to get money to pay for 100 million man hours of curatorial activity? You can't. No one can touch that. Not the biggest. The BBC is the world's largest broadcaster, and they've given up completely on maintaining their own internal vocabularies. So this is a big topic, because American news organizations are like, we have to be right. And the BBC has taken a different approach to that, more like Wikipedia, which is, we'll try our best, and so it's the best efforts. It's the best effort system, and we don't represent that we have the authoritative point of view on anything. But our sense is that ultimately the community will get it right, and that ultimately plurality is a more precise mechanism than having a sort of single authoritarian canonical answer. And I'll just say, if you look at Wikipedia, you talk about right. Look at the history of aviation page in French, and then look at it in English. They're very different. One is Icarus, the other is the Wright brothers. Who's right? You know what I mean? So that's an interesting question, just right and wrong, and truth online. So, yes, there's mistakes, for sure, but there's also things that are just culturally one way or the other. Let me just move aside. You had questions about images, so I felt you should get a chance to ask your question again.
Just out of curiosity, could you apply the same technology to artistic images? And if so, would it be helpful to have a database of 1 million images?
So yeah, you could apply. I mean, Aurora has been applying this technology to the entire collection of the Rijksmuseum in extraordinary ways, and you should go to her webpage and read about what they're doing for those artistic images, because, I mean, they're building personalized walking tours using a single image as a seed concept, and then it constructs a proto-narrative, and it downloads it to your iPhone, and then you can cruise around the Rijksmuseum and experience, so absolutely. You can apply these, I think, techniques to virtually any kind of data, image or otherwise. I'm going to just move back and forth, and I'll come back over. Let me get this poor guy first, and then I'll come back to you.
Are you considering integration with document archives, equivalent to something like what Ancestry does? So being able to search document archives, integrate them, bring them in, and then be able to do the metadata searches across them.
So, once you move into this kind of world of linked data or linked open data, Chris talked about the technology. The idea was that you could use the web as a kind of big document database, right? So that you would be accessing databases using web standards. So these projects we're working on, we're not just linking to other images. We're literally linking to documents. We're linking to pages. We're linking to Twitter accounts. We're linking to, right? It's just everything gets tied together. So it's funny you mentioned Ancestry.com. We actually spent a little bit of time with those guys. They're interested in anything that has any image that has a location, a date, and a name, right? Because what do they want to do? They want to tie that together with, just as you said, documents, right? Because people want to they want to light up this kind of content with visual data. So absolutely. I'm going to go over here, and then I come back over here. Yes.
So I just have a couple questions. Like, if you guys take into consideration any kind of like contextual awareness, specifically, I'm talking about like a user's practical interests when they're looking stuff up. So I think that the interests of someone who's living in New York or is just searching in New York, like say the relationships between neighborhoods in Brooklyn, is pretty important for someone who's in New York. But if you're like in Hong Kong, like it's not as important. And I guess that also kind of just teases on the kind of like, when you're talking about competing tags, like, like when the people disagree, I wonder if like you kind of take into consideration maybe like cross-cultural stuff and then like geographic, like so people in, Garrett, Indiana, they really want to know XYZ about New York City, but they really don't care about anything else. You know what I mean? Like, is that something to consider?
So, yeah, you're asking a great question. And, to me, this gets to sort of the you start to think about personalization, right? And you start to think about personas, right? Because we all have different personas when you think about information-seeking behaviors. You might demonstrate one behavior at work, where you're a UX designer and you're looking for something very specific, and then you go home and you're planning a vacation and you're in a same guy, but now you have a different persona and your needs, your information needs are different. And so this is what we try to model when we start to think about personalization. So we're sort of building this data layer independently of those things, and then we try to build, much like I think what Chris was talking about in his talk, where he said there's maybe 100 different algorithms that are getting to the right answer. I think you've got you start to model those things on the retrieval side, but you're absolutely going down the right path from my point of view to start to think about supporting different kinds of user roles, different kind of personas, and not having this is why we kind of built this idea of a hypermedia API. Ultimately, we want people to just get into the data and build the kinds of things they want to build out of it. We're not trying to present any kind of canonical view of this, right, as much as just make the data accessible to web developers with standard web tools.
Okay, we'll take one more question.
This one's a bit of a fun one. We've seen with the internet how tools like YouTube and Photoshop have like open doors for people to create and remix or mass up content. And I'm thinking that, with metadata for visual information, that it would open even more doors. I'm just wondering how long do you think it'd take for us to get to a point where, say, I could, with my keyboard and mouse, generate a movie with, say, Christopher Nolan's directing style and the likeness of, say, a Bryan Cranston?
So, it's a great, kind of an interesting question, and I think right on. So there was a European Union funded project called Media Mixer that we were involved in, and that some of this technology actually came out of. And the idea behind Media Mixer was to sort of fragment all of the kind of visual content. And then, you think about these applications like Photoshop or Final Cut, or, they all have some sort of idea of a media library or clip store. So what if the internet was, in fact, our clip store, and we could just bring these things together and create any kind of mashups? And this is, the Mozilla Foundation is funding this with, if you're familiar with Popcorn, there's a whole tool for, it's like a video NLE, nonlinear editor, but it runs in JavaScript in your browser, and you can just drag components together. So that's pretty cool. And then the next question is, could you make a playlist, right? Could you, and this is where the computational piece gets exciting, right? Could we pull a Pandora on YouTube, right? Could we take that data and then string that together in some kind of a way that was engaging, right? And so to me, like, the kind of holy grail for this is, kind of like a entertainment or playlisting app over just networked audio visual content that brings in your preferences and those personas. So that you sort of describe the end state that we're thinking about. There's a way to go, but that's the right kind of thought process. So I think we're out of time, or at least for questions, but thank you guys so much for having us. It's a pleasure to be here, and we really enjoyed it.